starting with what a 3D printer actually is and what it does. This is basically a machine that feeds in a roll, which we call filament, of plastic that usually has relatively low melt temperatures. So as it's feeding into the nozzle here, it's melting and laying a layer based off of code that you give it through a computer. So you would load your file into a program called a slicer. That slicer basically comes up with the coordinates that the printer needs to move in to create the shape that you want. And it's making the shape layer by layer, adding that plastic down until your part is built from the ground up. The reason we have different types of filament for 3D printers is because they're good for different uses. A lot of filaments are good for just aesthetic models that don't really rely on any strength or toughness. Others are really good for structural components that you're creating. Others are really flexible, so they're good for hinges, things that need to bend a great amount. A lot of filaments have added materials so that they're stronger, added materials so that they're more flexible, added materials so that they dissolve faster and you can rip off the support material easier. It just kind of depends on which problem you're trying to solve. So this was actually a request that came from our friends at the Marine Corps. They had wanted something like this information a long time ago, and they'd gone to several different companies to try to collate this information. And when we heard about the problem of them waiting so long to get this information in the hands of the warfighters, we took it upon ourselves to kind of collate that information for them in a matter of weeks rather than months. Marines aren't usually trained in material science, which makes it a lot harder for them to choose which filament is going to be best for their use case, which is exactly where our guide comes in handy because we've already done all of that work for them. So there's two levels on how you can use this filament guide. One is kind of the beginner's version, which has to do with these sidebars here. As you can see, we've kind of created different material properties that aren't real material properties. They're subjective terms that we've created to compare across all of these filaments. If you look at these across the row, you can compare, for example, how sturdy one filament is to another, how flexible one is to another. It really helps narrow down those really important properties in a quick and concise manner. The other way to use this guide is kind of our advanced version, which has to do with these radar graphs at the bottom. Now with these, you can line them up page by page, stick them up to the light, and see exactly how specific material properties compare across filaments. This is kind of more for our people that are a little bit more familiar with material properties and material science, but once you get comfortable with the beginner side, you can definitely jump into those radar graphs and get a firmer understanding of what's going on scientifically. Thanks so much for watching. If you'd like to see more content from Building Momentum and the really cool projects we get to do, go ahead and follow us on our Instagram. We also have a LinkedIn account and a Facebook. If you want to get your full copy of the filament guide in its full glory, check out the link below in the description. I'm going to be an electrical engineer, a mechanical engineer, a YouTuber, maybe an interior designer, and then an artist.